Yeah, that'll work.
Thanks, sir. So friends, real quick, before we get back into variation, Nick reminded me of something I wanted to share with you. On Fridays, my goal on Fridays is I'm going to record video solutions to all the quizzes you guys turn in that week. So if you look back to the quizzes from last week, I've done solutions to all the quizzes, video solutions. Some of them are me like in front of the board, like working through things. Some of them are just me talking with an Excel spreadsheet open. So in case there's other questions on quizzes, quiz solutions and things like that, you can check out the solutions. Again, this is why it's important to turn stuff in by the due date. Now, I understand that I have a rainy day quiz coupon where you can make up your lowest quiz, and I also realize the solutions are then out there. Yay! Again, it's one more resource. Then you can go back and look at a solution and be like, oh crap, I forgot to carry the 1. Or oh crap, I forgot to divide by 2, or whatever you forgot to do. But it's just one more resource. So that's the idea of having the solutions posted for you guys each week. So every Friday I'll post quiz solutions from the previous week. Make sense so far? If time permits, I'm also going to want to do project solutions too. Hopefully I can get those done. But hopefully, yeah, if time permits, I will do those as well. So, cool so far? Make sense? Good. Good. All right. Now, I want to revisit. This. Yes. I want to talk about what Alan dropped into our lap before break, which was, is there a way to quantify? Say it again, Alan. The way you said it was perfect. I'm going to murder it.
I don't remember.
It was 10 minutes ago. Damn it. What's happened since
we
then?
have it on record.
We're caffeinated now.
I'm just curious if there was a way to find the disparity between the measure of center.
Is there a way to talk about pick a measure of center that you want to use?
81.
81. I think that's fantastic. So in other words, can we talk about disparity from average? And I love that because that's technically exactly what most statisticians do. When they talk about variation, generally it's variation from the mean. From the mean. Or average, or X bar, what do you want to talk about? Yeah. You can measure disparity from any center measure, but the one that's usually used is disparity from the mean, the center. Love it. Love it. Good, good. Okay, so here's our image. Let's look at Ernie first, because he obviously has less disparity, yeah? He obviously has less disparity. So here's the average for both Bert and Ernie, right there. Can we talk about his individual test scores and how they're different from that average of 81? Good! Tell me! For example, 79. How is 79 different than 81? It's 2 down. It's 2 below. Good. How about 81 itself?
It's right on.
It's right on. No deviation, no variance, what was the word you used?
Disparity.
Disparity. No disparity at all. Love that. Dispersion, disparity. Good. How about this 82?
1 above.
1 above. Good. I'll tell you what. Let's do this a little more concretely. Let's make a table and keep track of our calculations. I love what we're doing, but I also know that sometimes conversational mathematics isn't the greatest, especially when you're learning a new idea. So let's talk about how we're going to measure this bad boy. Then we'll measure Bert's as well. Okay. So x. When you see x by itself, what is that?
Group of data.
Just data. So I'm going to take a laundry list of the x values under here. We had an 81, we had an 83, I think it was a 79, 82, and a 80 even. Thank you, friends. Beautiful. There's our data. There's our data. Let's have a next column. We're not going to have a frequency column because it's raw data, so the frequencies are all 1. That seems like a wasted column to have, I think. So let's just keep going. I'm going to add another column on here. And we're going to keep track of these dispersions, these disparities that Alan's talking about. So I'm going to take each data point, x, and I'm going to subtract the average x bar. That's an x. Sorry, it's like a y. So all I'm going to do is take that 81 away from each data point and see what I get. Which we just did. 3 of them, didn't we, conversationally? I think we did 81, didn't we? All right, that was 81 minus 81, which was 0. No disparity at all. So that number that you're getting is the disparity from average. 83 minus 81? is positive 2, which just means it's 2 above average. That's the variation from average of that data point, it's 2 above. 79,
-2.
excellent, is -2. That means it's 2
Below.
average, beautiful. 82 minus 81,
1.
that's a positive 1, meaning
1 above the average.
1 above average, love it. How about 80 minus 81? -1, which means it's 1 below average, love it. Excellent, we now have a measure of disparity of all the data points from average. That's a beautiful way of looking at it, actually. Thank you guys for leading us down that path.
If you organize them from smallest to largest, we have 0 in the middle, which is what 81 is. So
Did you catch that? What Nick is telling us to do is actually fuse both worlds. He's telling us to find the median of our disparities. The median of our disparities. Does that make sense? If you arrange those in order, you've got 0, 2, -2. Well, actually, you would go -2, -1, 0, 1, 2. I'm curious. Hold that thought. Hold this computation momentarily, if you will, friends.
hold it.
I want. That's awesome. Let's take a look at Bert real quick. Let's take a look at Bert real quick. Let's see if that's consistent. There's a hypothesis. If we take the medians of the disparities, 0's in the middle. Now, take a look at Bert. Will that happen with Bert?
No, but I don't think he's saying that that's going to happen consistently.
Oh!
It just happens to be that in the case of Ernie, that's how we can see their differences in
I
variation.
didn't think about that. But
Thank you, Carly. I didn't know that's what I meant. I remember Steven Tyler in the movie John Travolta, Steven Tyler, Andre Benjamin. Great movie. But John Travolta's telling Steven Tyler what he wrote Sweet Emotion about. He asks him, what is Sweet Emotion about? He's like, oh, wasn't this time of my life, and blah, blah, blah. And Travolta's like, you know what, I don't think you wrote that about that. So I'm having the same moment right now. I apologize, Nick, for telling you what you were thinking. My apologies. So, not in general, but what would that help us, if 0 being in the middle, would that mean that there is no variation with Ernie? I guess what I'm asking about is now, what is this, if it doesn't mean median, what does that 0 in the middle mean? Why go to the middle of the variation anyway? I guess another question now leads off a question.
because that's what the 81s are, and the 81s are the
Absolutely. I noticed that Bert's middle would be positive 1, wouldn't it? Because he's 1 above average. So that would be his middle. But then the problem with that now, yeah, hang on. The problem with that is that positive 1 above average and 0 above average, they seem very similar, don't they? It almost seems like they're not different again. Jolene, you want to say something over here, I think.
Well, okay, so before we went to break, I took Bert's range and subtracted it from his highest and lowest score.
Okay,
Or from 81,
from 81.
So from 42 to 120. And then from what Nick's comment was, and from the 4 from Ernie, I noticed that if we split those numbers in half and subtracted them from 81, we would get both Bert and Ernie's highest and lowest scores.
What you just described is absolutely gorgeous. And it's actually tied, you essentially played checkers and jumped over a piece to get to where the most used measure of variation is in the world. Can I pause it for a little bit? Because I want to come back. What we've got over here, what Jolene's describing, is actually called the idea of a number of standard deviations from mean, but it doesn't use the range, it uses something else, and that something else is what you guys are smack in the middle of discovering right now. So rather than get 2 paths going, if you don't mind, I want to come back to that, because that was wonderful, 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 wonderful. Back to Nick! I'm not letting him off! What the hell is that 0 in the middle talking about? Here's my vote. I don't think we should look at the 0 in lieu of the other numbers. That's my vote. I think we should look at all the numbers, because all the numbers give us an idea of disparity, yes? So I guess my question for you all is, what should we do with these numbers?
Put them in order.
Put them in order. We did. It was -2, -1, 0, 1, and 2. Now, can you collapse them down to one number? I want a quantification, right? Like what I want is, I like the range, and the idea that here's Bert's range, here's Ernie's range, and we can compare them directly. Now, we just realized one of the limitations of that. It ignores the average. What we now have are 5, if you will, different data points that are, if you will, transformations of the original data points. What can we do with these? We put them in order, but that still gives us 5 data points. One vote was to use the median, But the median, unfortunately, it loses the tails of those. Nick, go.
Could we do mode?
Can we do mode? Sure, what's the mode? I love that.
There are 5.
There are only 5 of them.
No, there are 5 modes. They all.
Well, technically there are either 5 modes or there are no modes, depending on how you look at it. Good. So you're either going to have no mode at all, which doesn't help us, or you have 5 modes because all data points are unique, which doesn't help us either. Thank you for that. Please, Veronica.
Could we take the average of those?
Could we take the average of them? Please, let's average them.
It's still 0.
The problem is it averages to 0. Why? Why does it average to 0?
Because the negatives and positives.
Because the negatives and positives cancel. And here's something to think about. I'm going to go back to Bert for a second here. If you look at Bert's disparities from average, just so you know, this is the kind of stuff the tutors do with you. They don't tell you the answer, they draw it out of you like I'm doing with you. And hopefully it's not infuriating you too much. If you look at Bert's disparities, keep an eye on Bert's disparities, right? 100 is 19 up from average, correct? 81. So 19 up. Somebody keep track of this in your notebook. 19 up. This is 94, which would be 13 up. 82 is 1 up. 68 is negative 13 down, I believe. Yes, negative 13. And then 61 is negative 20 down. So you got negative 20, negative 13, 1, 13, and 19, yeah?
They're about the same.
Average them. What do you get?
0.
You get 0. Here's a truism. No matter what your data set, you've opened a can of worms here, Adam, I thank you for it. No matter what your data set is, if you form this column right here, sorry about that. I'll try to do that again. I've already scared you guys like 3 times this morning. If you form this column, this will always sum to 0. Now, it's a neat little algebraic happenstance. It has to, because of what it is. I've actually put it up for extra credit in your homework. There's a problem in your homework for this section that says, prove to me in any way you can why. So in other words, for any data set whatsoever, prove to me why. But don't worry about that right now. I'm not going to prove it on an exam or anything like that. Why, or speaking not why, how do we deal with that? Veronica, be very patient. Go.
An absolute value.
That's a great solution. One thing to deal with it would be take the absolute value of the numbers. Now, if we do that, what do we lose? Be brave, be brave. Kelsey, go.
Whether
Kelsey.
they're higher or lower.
First, Kelsey, first of all. Yes, good. You lose whether it's higher or lower, but that doesn't exactly lose what Alan was talking about, because he's just talking about disparity from average. So negative 2 and positive 2 are both too distant from average. So one way to deal with it is take the absolute value of all these bad boys, and then average those absolute values. I'm going to leave that at that right now, because nobody actually does that statistically. It's called the average deviation. It's my personal favorite. But mathematically, it doesn't work out inferentially, which is, I think, why it gets swept under the rug. Thank you, though. It's perfect. It does exist. I like it. It's logical. It's perfect. It's beautiful. Nobody uses it. Unfortunately. Kind of like democracy. Carly, go!
If you just look at the range
Yes.
of those deviations,
Yes.
and then you look at the range of deviations for Bert's,
Yes.
then you'll be able to see a difference between how far away they're deviating from.
So you're saying like the high and low numbers of the ranges versus Bert's high and low numbers of the ranges? So like negative 2 to 2 versus whatever it was, negative 20 to 19?
Mm-hmm.
I love that, I love that, I love that, I love that. The problem with that is, and it works great in this case, what if we don't have such uniformly spread data through the range? Suppose Bert had a glut of numbers up top and then he had 1 down the bottom. Now granted, you're going to have a different range. You're probably going to have a much smaller negative and then a much smaller positive, actually, because the negative is going to get larger, more negative, which makes it smaller. So I like what you're saying, but I don't think we can pick and choose. I think we have to use all of them. I love what you're saying, but in general, we want to use all of the values at the same time. Is that believable?
Yeah.
If not now, hopefully we'll be in 5 minutes. So the idea is, what can we do to save this beautiful set of data right here? We can't take the absolute value because it distorts the data a little bit, unfortunately. And you'll see why more in 244. I'm going to leave that there. Press the pause button on that one until 244. Here's what's and this is the non-counterintuitive part. Here's the non-counterintuitive part. What statisticians have done is to get rid of the negative in a non-destructive way. They take those deviations and square them. This is not going to make sense unless you look at it mathematically, which I do not want to force you to do. Because mathematically, looking at this, it loses all interest in it. If you're interested, and I hope that you are, I've got a proof of why this works on that enrichment page of your website. By all means, you can get in there and take a look at that if you want to know why this is the best way to deal with it and not the absolute value. It's unfortunate. I actually had to answer this question. The YouTube videos you guys sometimes watch, people send in comments from all over the place. And they ask me, why square? Why not take the absolute value? And I got this great mathematical discussion with this guy from like Zimbabwe or something. And it's valid mathematics. But I've also noticed that I put students right to sleep if I try to get into it too much in class. So I won't. I'll offload that to the enrichment page if you're interested. All right, what would this be? Well, this squared, this squared, this squared, that squared, and that squared. So it'll be 0, 4, 4, 1, and 1. Now, there's a problem with this, obviously. What's the problem with squaring the deviations? Or the disparities? I keep saying deviations, that's the more traditional word. I like disparity, though. When you square them, what do? You make them kind of artificially larger, right? So Carly's going to say, what the hell? When Bert had a negative 20, it's now a positive 400, first of all. That's way more ridiculous than squaring a 1 and getting a 1. Yes, we can take care of that with the square root later, I promise you. We'll deal with that later with the square root. What's another problem that if we could just use Veronica's awesome idea would be eradicated? Nick?
Could it be because of the mode now that we have?
Well, actually, we do have a mode, don't we? Freaking modes. This is great. I wasn't even thinking that. That's a good point. I was thinking, what are the units on the original data? 81 what?
Points.
Points, right? Points. Points, 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 points. What are the units here?
Point squared.
Square points or points squared. What is a square point? It doesn't exist, does it? A square point is like a squared dollar. Right? That doesn't make any sense. Right? But if you take dollars and square it, like if you're measuring the variation in state spending across the country, you'd square dollars and get square dollars. Now, we'll deal with that by taking a square root later, I promise you. The last thing we'll do is take a root and it'll fix everything and things will happen again. So, but right now, we got an issue. All right, what should we do with this? I'll make sure the camera's pointing in the right place. What should we do with those square deviations? Gesundheit.
It is.
What should we do with them?
Take the average.
I love it. We are now going to take an average of those bad boys. Yes, we said that. It was beautiful. Whoever said it was right. We like our averages in statistics. We do. We like our averages. We do like our averages. So what I want to do is I want to look at these. I want to erase these beautiful ranges. I apologize. So the first thing we're going to do is we're going to add those bad boys up. We're going to add these guys up. This is called the sum of the squared deviations. You will see this sometimes when you guys read your journals in your psych or your SOC or your natural resources or your HDFS. You're going to see something called sum of squares. And although there can be different sums of squares depending on the data, it always refers to the same thing. You're looking at all the data, how it's deviant from average, and then the square of all that. So, our sum of squares is going to be 10 squared points, whatever the hell that means. 10 squared points, which is silly. All right. Now, we mentioned averaging. Yes, we're going to average these bad boys. Here is the most confusing part of all of Math 243 and Math 244. The most confusing part. What you're about to do is take the average of this. The average is called, in this case, the sample variance. This is a title. This is called a title. It's called the sample variance. It's a very specific measure used in statistics. We're only going to use it one time in Math 243 right now, because it's an intermediate step when you're crunching this stuff by hand to get to what we really want, which is what Alan painted the picture for half an hour ago, which was the measure of dispersion. Cassidy's like, I should have never showed you this class. I should have never done this. It's ridiculous. He promised me no math. That's all I'm doing is math. The sample variance is found by taking that sum of squares, which is up here, and dividing, and this is the somewhat confusing part. This is the most confusing thing in Math 243. Not by 5, but by 4. You divide by 1 less than your sample size. I have three quick explanations as to why you would do that. Let me share with you momentarily once we crunch the numbers in our example. That's probably Cassidy, go. N minus 1, 1 less than your sample. We have 5, we're going to divide by 4. People are saying, wait a minute, that's dumb, why would you do that? I want to come back to that. There's a few reasons, one of which is a long, drawn-out reason, which is proved on the enrichment page for you, so I don't put you to sleep. But there are a couple of good reasons as to why we do that. Exactly, we're getting there. So for our example, for Ernie, the sum of the squares was 10 points. We divide that by 4. Oh, thank you, Nick. Appreciate that.
Yeah.
Power man. Awesome. We divide that by 4 to get 2.5. Square points. We're still, don't forget the units. I mean, you probably did. That's okay. It's early in the morning. 2.5 squared points is silly. It's a silly measure that doesn't really mean a whole lot. So what we're really after, I want to come back to this N minus 1 briefly, momentarily. What we're after is not squared points, but just points. So how do we fix the problem? That's how we fix the problem. And that's called, my friends, the sample standard. We're getting to you over here, Jolene. The sample standard deviation. This is what you were alluding to earlier with what you were talking about beautifully. This guy's so special, he gets his own letter. We call him little s. We call him little s. And he is the square root of the sample variance. Sample variance, as you may have guessed, is s squared. But don't commit it to memory. That's just, it's an intermediate step for us. We don't need it except to get to here. So that's going to be the square root for us, the square root of 2.5, which is going to be, give me to 1 decimal if you would.
1.58.
1.58, beautiful, I'll take 2. And the thing I'm most happy about is it's 1.58 points. The unit agrees with the average. So a way to measure the disparity or the dispersion of Ernie is to say, yeah, he had an average of 81. He had an average of 81, but he had a sample standard deviation or disparity of 1.58 points. And I want to come back to exactly what that means momentarily. I want to make sure you understand why we're dividing minus n minus 1, at least conversationally. You're drawing a sample. Don't commit this to memory. Let this wash over you. You're drawing a sample, which means you have some uncertainty in your sample. If you divide by n minus 1 versus n, you're going to get a slightly larger value for your sample variance than you would in your population variance. That eradicates a little bit of the uncertainty by making the plus or minus wider. So you're admitting, if you will, an error in that. That's one kind of way of thinking about it. Another way of thinking about it is something that I'm going to mention, I'm going to put it in the back of your mind right now. It's called degrees of freedom. You might or might not ever see these again. Technically speaking, your degrees of freedom are how many variables algebraically you have to define until the rest of them are determined fully. You studied this in algebra class, which is probably why you don't want to think about it anymore. But because this computation was based on the average, you don't need as many degrees of freedom because the average is already part of that, as opposed to taking an average which you don't have any variables first. So the big thing is, the reason why you're dividing by n minus 1 is a mathematical one for the most part. If you really need to know why, I encourage you, go look at the enrichment page and there's a walk down as to why it's n minus 1 and not n. I know it's totally counterintuitive right now and I apologize for that. But nonetheless, that's kind of unfortunate. Let's focus instead on what this means. Nick, would you mind starting and stopping or stopping and starting? I want to talk about what this means.